Hey everybody, this is our lesson on colligative properties, and by the end of this lesson you should be able to summarize the properties of solutions. Before we get started though, make sure you review vapor pressure, boiling point, and freezing point. This lesson is very easy. It's not a hugely tested area other than just knowing the relationships, so this one should go pretty quickly. So first, let's talk about colligative properties and the first one, which is vapor pressure lowering. So a colligative property is a property that is dependent on amount dissolved, not on the composition of the substance. And our first one that we look at, like I said, is vapor pressure lowering. So the more solute you have dissolved in the solvent, the more decrease in vapor pressure you will see. Remember that vapor pressure is defined as the pressure of a gas above a liquid. And when you dissolve more solute in solution, your particles in the solvent get preoccupied and do not go into gaseous state as much. So as you can see, you've got some of these water molecules going off into gaseous state. Well, as you dissolve stuff into the liquid here at the bottom, they are going to be surrounding the ions that are present, which means they won't break off and go into gaseous state as quickly. Our next one is boiling point elevation. And for this one, again, the more solute you dissolve, the higher the increase in boiling point. So remember that boiling point is the temperature at which your vapor pressure is equal to the atmospheric pressure. So sometimes if people say, oh, you want something to boil faster, you need to put a lid on it because that's going to allow you to build up that vapor pressure. Well, when you dissolve more solute in solution, if that causes the particles to be more preoccupied so they lower the vapor pressure, they don't go into gaseous state as easily, that means you got to add more heat to make them go into gaseous state. And that's why your boiling point is actually going to be higher with solute dissolved. So when you dissolve salt in water, a lot of people think to make water boil faster, you put salt in it. That actually causes it to boil slower because you have to get to a higher temperature. Instead of 100 degrees Celsius, it might be 101. It's not a huge change, but it is a change. But if you put salt and water to cook things, it will actually allow them to cook faster. So now let's talk about freezing point depression. So if putting in a solute causes us to increase the boiling point, it's going to do the opposite to freezing point. And depression, we know, means to go lower. So as you dissolve more solute, you will decrease the freezing point. And that's because the particles will disrupt the freezing pattern. So as you can see here in this GIF, it was very organized until you started adding those ions in that were dissolved. And to allow those particles to still freeze again, you actually are going to have to cool it off even more. So this is why, let me go back. This is why we actually put salt on the roads in the wintertime, because as the rain and sleet and snow hit the salt, they actually melt, and it will keep the roads from freezing. The roads would have to get much, much, much colder to freeze and cause those issues. However, the problem here is we put the salt out too early, and then rain washes it away, and then it's not there to do its job. So I want to jump back quickly. Let's go back a couple slides because there are some boxes on your notes to the side. You need to know the relationships here. So if more solute dissolved means a decrease in vapor pressure, that means the vapor pressure of the solution is lower than the vapor pressure of the pure solvent. So the vapor pressure of the solution is lower than the vapor pressure of the solvent. For boiling point, as you increase or as you dissolve more solute, you increase the boiling point. So the boiling point of the solution is greater than the boiling point of the solvent. And then for freezing point, since you have to cool it off even more to make this occur, the freezing point of the solution is lower or less than